Welcome back, everyone, for another deep dive. This time we're getting into something that's really at the heart of what you do as a technical program manager,
Mm,
system design. And, we're not just going to skim the surface here. We're going deep into the why behind the what. So you can really step up your game when you're talking with your engineering teams.
absolutely. I mean, as a TPM, you're kind of in this unique spot, right? You need to grasp the technical
Yeah.
stuff deeply enough so
Hmm.
you can make those smart decisions, foresee those roadblocks,
Yeah,
and ultimately steer your project to success.
totally. So let's just kick things off with like a really basic question.
Sure.
Why should a GPM even care about system design? I mean, isn't that like the engineer's territory?
Yeah, it's true. The engineers are the ones actually coding and building the systems.
Right.
But think about it this way. You wouldn't build a house without a blueprint, right?
Yeah.
System design is kind of like that blueprint for software projects.
Oh,
It maps out the structure, all the different pieces, and how they all work together to actually do what you want it to do.
okay. Yeah, I see that, the
Yeah.
analogy. But blueprints can be, well, pretty complicated and technical, right?
For sure.
How deep down the rabbit hole does a TPM really need to go?
You don't need to be a coder yourself,
Okay.
but getting those core system design ideas will help you talk the engineer's language,
Right.
ask the right questions, and make sure that all those technical choices are actually lining up with what the project needs.
Makes sense. So where do we even start with something as big as system design?
A really good starting point is understanding those different architectural patterns that people use all the time.
Okay.
You've probably heard terms like monolithic
Yeah.
and microservices get tossed around.
Oh, yeah, for sure.
So picture a monolithic architecture, like one big, tightly knit unit, like a giant machine where every piece is linked together.
Okay, I can see that. And what about microservices? I feel like I hear that one everywhere these days.
So microservices are more like a bunch of smaller, independent services
Okay.
that communicate with each other, like a city
Uh,
with all its different neighborhoods. Each one has its own thing,
yeah.
but they all work together to keep the city going.
So if monolithic is like one giant machine,
Mhm.
microservices is more like a network then.
Exactly. And, each approach has its pluses and minuses. Monolithic architectures
Yeah.
can be easier to develop and get up and running at first,
Mm-hmm.
but they can get trickier to scale and maintain once the system grows bigger.
So if you're thinking your project might get really big
Right.
or needs to be super flexible, macroservices might be the way to go.
Yeah, you're getting it. Microservices give you more wiggle room and scalability because you can tweak individual services without messing with the whole system.
That makes sense. But I bet managing a network of all these separate services also has its own headaches, right?
Absolutely. Communication overhead, keeping data consistent, and dealing with all those dependencies get a lot more complicated with microservices.
I can imagine.
And that's where you, as a TPM, become even more important.
Okay, so I see how understanding these architectural patterns can help a TPM ask the right questions,
Mm.
like right from the design phase,
Yep.
and make sure the team is thinking about the long game.
Mm.
What else should TPMs have on their radar when it comes to system design?
One of the biggies is understanding how the system will handle data.
Okay.
This means thinking about how it's stored, accessed, and processed.
Yeah.
It's called data modeling, and basically it's about designing how your data is structured to make sure it's efficient and can scale.
So is data modeling kind of like creating the filing system for all the info the system is going to be dealing with?
Exactly. That's a great way to put it. And just like a well-organized filing system makes it easier to find stuff.
Right.
A good data model makes your system run smoother and faster.
Now that makes me think about APIs, those interfaces that let different parts of a system communicate with each other.
Yeah.
How does a TPM need to think about APIs in the context of system design?
APIs are like the messengers, right? Carrying information between different parts of the system,
Okay.
whether it's internal or even to outside systems.
Yeah.
It's really important for TPMs to understand how APIs work and to push for good API design.
Why is good API design so crucial for a TPM?
Well, a well-designed API, it's like having a clear, straightforward conversation between different parts of your system.
Yeah.
But if the APIs are poorly designed, it can lead to all sorts of mix-ups,
Mm-hmm.
errors, and delays. It's like trying to talk to someone who speaks a completely different language.
Right.
It's like you said, a well-defined API, it's like a contract,
Right.
Make sure everybody's on the same page.
Yeah.
And as a TPM, if you can look at API documentation, you can help avoid those integration nightmares later on.
Makes total sense. Don't want those components talking past each other.
Exactly.
So we've got the architecture, the data's all neat and tidy, our communication channels are clear. What are some other things, like key system design considerations that TPMs should keep in mind?
One big one is understanding how the system will handle growth, like when demand goes up.
Right.
Imagine you have this huge surge in users, or the amount of data you're processing just skyrockets.
Oh, yeah.
How do you make sure the system can keep up?
That's where scaling comes in, right?
Yeah.
I've heard about vertical and horizontal scaling. Can you break those down for us?
Think of your system like a car engine, right?
Yeah.
Vertical scaling, that's like adding more horsepower to the engine.
Okay.
You're making the existing machine stronger.
Got it.
But horizontal scaling, that's like adding more cars to the road.
Okay.
You're spreading the load across multiple machines.
So if my system is starting to slow down,
Yeah.
I can either beef up the server
Yeah.
or add more servers to share the workload.
Exactly. And there are trade-offs with each approach. Vertical scaling can be easier to do at first,
Yeah.
but you'll eventually hit a limit on how powerful you can make that one machine.
Right.
Horizontal scaling lets you grow more dynamically, but it gets more complex, managing all those machines and making sure the data stays consistent.
So it sounds like really understanding how scaling works is super important for a TPM
It is.
to foresee bottlenecks and push for the right solutions.
Yes, absolutely.
Right, from the design phase.
From the beginning, yeah.
And it's not just about scaling the servers, right?
Yeah.
You also have to think about managing the flow of all that data and the requests as the system gets bigger.
Right.
That's
Yeah.
where things like load balancing and caching come in.
Yes, exactly.
I've heard about load balancing. Is that sort of like having a traffic cop directing traffic to different servers?
That's a great way to put it.
Great.
Load balancers, they're like smart traffic directors.
Yeah.
They spread out those incoming requests across all the servers, so no single server gets overloaded.
Right.
That's key for keeping things running smoothly and making sure the system is available as it scales.
Okay. That makes sense. And what about caching? I know it's about storing data to access it faster, but how does it fit into the whole system design picture?
Okay, imagine you're browsing a website
Yeah.
and you keep going back to the same page over and over.
Yeah.
Instead of grabbing that page from the server every single time,
Yeah.
you can keep a copy of it on your computer's cache so you can access it faster.
Okay.
That's the basic idea behind caching.
So it's like keeping the info you need most often right at your fingertips.
Yeah, exactly. Caching can make things so much faster, especially for data or operations that are used a lot.
Right.
But you got to be strategic about how you manage caching too.
Oh, okay.
You don't want to cache everything,
Right.
and you need to make sure the cache data is up to date.
Makes sense. You don't want to show someone an old web page just because it was pulled from the cache.
Exactly. That's the last thing you want.
So it's about balancing speed with data freshness.
Yes, finding that sweet spot.
Okay, cool. What are some other challenges that TPMs should be aware of in system design?
One area that can be tricky is understanding fault tolerance. Imagine a critical part of your system just fails. What happens? Does the whole thing crash?
Right.
Or does it handle failure gracefully and keep going?
That's where redundancy and failover mechanisms come in, right? I've heard those terms before.
Yes. Fault tolerance is all about designing systems that can handle failures without causing major disruptions.
Okay.
Redundancy means having backups ready to go if the main component fails.
Okay.
And failover mechanisms make sure the system automatically switches to the backup if something goes wrong.
So it's like having a spare tire in your car.
Exactly.
Hopefully you never need it,
Right.
but you're really glad you have it when you get a flat.
That's a great analogy. What are some other ways to build fault tolerance into a system?
That's a good question. I'm curious about that too.
Another key thing is thinking about how you'll monitor the system's health and performance. It's like having a dashboard in your car that tells you if something's off.
Right. I see how monitoring is important, but how is observability different? Is it just having even more data?
It's more than just having a ton of data.
Okay.
Observability is about understanding why something is happening, not just that it's happening.
Oh, okay.
Think of your car's engine light coming on.
Yeah.
Monitoring tells you there's a problem.
Right.
But observability helps you figure out what's causing it and how to fix it.
So it's like having the tools to actually diagnose and troubleshoot problems.
Exactly.
What does a TPM do to make sure a system has good observability?
As a TPM, you can push for building observability in from the very beginning.
Okay.
This means making sure the engineers are putting in things like logging, metrics, and tracing.
Right.
So you can get a clear picture of what's happening under the hood.
You don't want to just be guessing about what might be going wrong.
No, you want to be able to see it.
Right, exactly. Okay, so now, as systems get more complex and connected,
Yeah.
security becomes a much bigger deal.
Absolutely.
We have to think about how to protect the system from, unauthorized access, data breaches, all those threats.
Definitely.
Security is a huge topic.
Mm-hmm.
What are some key things TPMs should be thinking about when it comes to system design and security?
Think of security like layers, right? You start with basic hygiene, like making sure all the software is up to date and using strong passwords.
Right.
Then you add more layers of protection, like firewalls, intrusion detection systems, encryption.
Like building a fortress around your system.
Yeah, exactly.
So what's the TPM's role in building this fortress?
Well, as a TPM, you're not the security expert.
Right.
But you need to understand the basics and make sure security is part of the design process right from the start.
Yeah.
You don't want security to be an afterthought.
So it's about asking the right questions, working with the security team.
Yes.
And making sure security is baked into the system design.
Exactly. Now, once you've designed your system, you have to think about how you'll get it up and running and keep it that way. That's where deployment strategies and operational considerations come in.
Okay, so now we're moving from the design phase into the deployment and operations phase.
Right.
What are some things TPMs need to know about in this area?
One of the biggest decisions is where you'll host your system.
Okay.
You could stick with traditional on-premises infrastructure,
Yeah.
or go with the cloud.
Mm-hmm.
Cloud platforms offer a lot of advantages.
Right.
Scalability, flexibility, cost-effectiveness.
Yeah.
But there are new things to consider too, like security, compliance, and vendor lock-in.
So choosing the right deployment strategy is a pretty big decision.
It is, yeah.
The TPM should definitely be part of that.
Absolutely. And once the system is deployed, you need to figure out how you'll keep an eye on its performance, manage updates, and handle any incidents that pop up.
Yeah.
That's where concepts like continuous integration and continuous delivery, or CI/CD, come into play.
CI/CD, yeah, I've heard those terms.
Yeah.
Could you explain what those are all about?
Think of CI/CD like a pipeline, right? It automates the process of building, testing, and deploying software changes.
Okay.
It lets you release new features and bug fixes faster and more reliably.
So it's like having a streamlined way to get changes from the developers to the live environment.
Exactly. And that can be a huge plus for agile teams that are always making changes and releasing updates.
This has been really insightful.
Good. I'm glad.
I'm starting to see how understanding all this system design stuff can help TPMs be more effective.
It's all connected.
Yeah, definitely. And we've just scratched the surface.
Oh, yeah. There's so much more to explore.
Wow. Yeah, there's a lot to unpack there.
Right.
But it's all really fascinating stuff.
I think so.
I'm definitely ready to hear more about what other system design secrets you've got for us.
All right. Well, let's talk about something that sometimes gets overlooked early on,
Okay.
but it becomes super important as your system grows: disaster recovery.
Ah, yes, disaster recovery.
Mm-hmm.
Hope for the best, but prepare for the worst.
Exactly.
What are the big things TPMs should be thinking about here?
Well, it starts with asking those tough questions right up front.
Okay.
Like, what could potentially go wrong in our system?
Right.
What's the absolute worst case scenario?
Right.
How much downtime can we handle?
Mhm.
Those questions lead you to figuring out your RTO and RPO.
RTO and RPO.
Yep.
I've heard those terms, but could you remind us what they mean?
Sure. So RTO stands for recovery time objective.
Oh.
It's the maximum amount of time your system can be down after a disaster before it starts really hurting the business.
Okay, got it.
And RPO, that's recovery point objective.
Mm-hmm.
It tells you how much data loss you can live with if a disaster happens.
So RTO is all about how quickly you can get back online.
Exactly.
And RPO is about how much data you can afford to lose.
You got it. And figuring out those objectives early on helps you make smarter choices about backups, redundancy, and failover mechanisms.
Right.
Like if your RTO is super strict, you might need to invest in some fancy disaster recovery solutions. Things like geographically redundant data centers.
That makes me think about backups.
Mm-hmm.
I know they're important.
They are.
But what are some things TPM should keep in mind when it comes to backup strategies?
It's not just about backing up the data.
Right.
It's about having a solid plan for backup and recovery.
Mm-hmm.
You need to think about things like how often you do backups, where you store them, how long you keep them, and, this is the big one, how you're actually going to get the system back up from those backups.
It's like having a fire escape plan.
Exactly.
It's great to have a fire escape, but you need to know how to use it if there's actually a fire.
Exactly. And you got to test those backup and recovery procedures regularly.
Yeah, that's a good point.
You don't want to find out your backups are corrupted.
Right.
Or your recovery process doesn't work when you're in the middle of a crisis.
Makes sense. You mentioned geographically redundant data centers earlier. Why is it important to spread things out geographically for disaster recovery?
Imagine all your servers are in one data center.
Yeah.
And then, boom, that data center gets hit by a natural disaster or a power outage.
Uh-oh.
The whole system could go down.
Right.
Having your infrastructure in different locations helps reduce that risk.
So it's like, don't put all your eggs in one basket.
Exactly.
If one location goes down,
right,
you've got another one ready to go.
And that's where cloud platforms can be really helpful for disaster recovery.
Okay.
They often have built-in features for replicating data and applications across different regions, making it easier to set up geographically redundant systems.
This deep dive into system design has been incredible.
I'm glad you think so.
I feel like I have a whole new set of tools now for understanding how systems work, what can go wrong.
Yeah, and how to make them stronger and more resilient.
What are some of the key things our TPM listeners should take away from all of this?
Well, I think the biggest takeaway is that understanding system design isn't just a technical skill.
Right.
It's a strategic advantage for TPMs. It helps you communicate better with your engineering teams, ask the right questions during design discussions, anticipate potential problems and risks, and make smart decisions that align with what the business needs.
It's about being a real partner to the engineering team.
Exactly.
Not just a project manager.
Right. You're part of the team.
Yeah. And system design is an ongoing journey, right?
Absolutely.
We're always learning and exploring.
The tech world is constantly changing, so stay curious, keep asking questions, and never stop learning.
That's great advice.
Okay.
So to wrap things up, what's one thing our TPM listeners can do today to start putting all this into practice?
I would say start by having a chat with your engineering team about their current system design approach. Ask them about the architectural patterns they're using, how they're handling scaling, what their disaster recovery plan looks like.
That's a great suggestion. Simple, but powerful.
Yeah, it gets the conversation going.
It's a great way to start bridging that gap between the technical and business sides of your projects.
Sure.
And on that note, we've come to the end of our deep dive into system design for TPMs.
It's been a pleasure talking about all this with you.
We hope you found this exploration helpful.
Yeah, definitely.
And that you're leaving with a new sense of confidence and a deeper understanding of how to navigate the amazing world of system design.
It's a fascinating world.
It really is. Remember, keep learning, keep asking questions,
Yes.
and keep building amazing things.